This is the very first video about our compiler project where we actually will implement our own compiler in ABC, and we will also call it ABC, a bloody compiler. In the end, this will be a simple compiler, but it will support, for example, variables, control structures like if statements, loops, functions. So by doing this project, you will understand how compilers work in general, and you will learn that by doing it by yourself. You will write this compiler. I just will give you in this sequence of videos some first initial ideas for certain components that you need to implement for a compiler, and in the exercise you improve these components. Even though our compiler in the end will be a simple compiler, we will start even simpler with something that you could call a bad calculator. What do I mean by bad calculator? Well, a good calculator would give you the result 7 if you type in this expression. Our compiler will generate from this statement actually just assembly code. It will not tell you the result. Assembly code like that. Load the immediate value 3 into register 1. Load the immediate value 4 into register 2. Then add register 1 with register 2 and store the result in register 3. Something like that. Then of course we will improve this so that you also can handle multiplication, and here it should be correctly handled that the multiplication has a higher precedence compared to the addition, so this should be handled first after the addition, things like that, and of course also handling parentheses in expressions. Once this is accomplished and works, you then can consider improvements like dealing with variables, control structures, stuff like that. And then, of course, in the end, a compiler also should be able to do computations at compile time where possible. So if you would have later an expression like x equals 2 times 3, the compiler should replace this with 6, constant folding. Okay, so this is the outlook, how this project will grow over time. But we will start here with just one component of this very first simple compiler, the component called a Lexer, or a scanner for lexical elements. Let me show you what this Lexer is about and what we will deal with in the next exercise. This here is an example for the Lexer of the ABC compiler. It reads in a source file like that, character by character, and then it recognizes in this stream of characters interesting things for this programming language, so-called tokens. For example, here it recognizes the keyword fn. And you see it's also keeping track of where this token was found in line 1, starting at column 1. Then it's ignoring, for example, here white spaces and new lines, and recognizes another interesting thing, this identifier main. Also in line 1, starting at column 4, and so on. And then you see, for example, this integer literal 42 was recognized here in line 3, starting at column 12, and it was recognized as a decimal literal. And in the end, it's also recognizing the end of input, EOI, when the end of file was reached. So with something like that, we will deal in the next exercise and also in this video. The Lexer I will show you will be much simpler. It will just consider decimal literals and the plus sign as interesting tokens. Then it's also recognizing the end of input, but anything else will be considered as a bad token, a token which is not specified for this language. So from this input, it will generate in the end an output like that. So if it's, for example, recognizing here this 12, it generates this output decimal literal. So it's not keeping track of line numbers and columns. This is an improvement we can do later. Then it's skipping over the white space, and when it's reaching the plus sign, it's generating this output, and so on. And when it's reaching, for example, this open parenthesis, it's generating a bad token output, and also for the close parenthesis. And then it actually should print end of input. So that's something I forgot, but that you easily can fix by yourself. So let's get started with that. This is the structure of the Lexer program that I show you in this video. Everything will be in one single source file. Later we will split this into 3 files. Then this will become part of the header file for the Lexer, lexer.hdr. The implementation for the Lexer will become part of lexer.abc, and function main will become part of the test program, xtest_lexer.abc. For the beginning, it's not that bad to have everything in one source file, because then it's easier to understand how things work together. Let's begin with the enum constants. For each kind of token that the Lexer can find, there is a constant. The Lexer can find a plus token, a decimal literal, the end of input, and anything else it finds in the input stream, except for white spaces, which will be ignored, will be considered as a bad token. To interact with the Lexer, you have to call this function getToken. What getToken does is it's reading character by character until a new token is found, and then it returns the token kind by its return value, which will be one of these constants. It will also change this global variable. So basically, it's not necessary to also return this token kind, but you will see it's convenient to also return it and also set this global variable. Because that means in this global variable token, you always have the value for the last token that was found. This will be very convenient. Before I show you the rest of the implementation, let me show you my workflow for implementing this, because this already should compile. In my workflow, I want to avoid situations where I type in a long program, then compile it for the first time, and then I have to deal with lots of error messages. Maybe just error messages because of typos. But this is for me a distraction that I want to avoid. You will also see that I use the following command to compile the program and then execute it, but only if the compilation was successful. And on the bash you can do that as follows. You specify the compiler, abc, lexer.abc, the source file, followed by 2 ampersands, and then the name of the executable. Okay, but now let's get started. You will see that I start very simple, just with a function main. That's it, and then I will already compile and execute this program to, for example, check that I'm in the correct directory or that the compiler is correctly installed. Then I set up this command which will compile, and only if that was successful, execute the program. And if I have an error, I go back, fix it, and test it again. And then I can start with the tedious things like the declaration of this enum type. And by the way, I'm not typing and talking. I find that very hard, and I enjoy it now to do reaction videos to my own typing. So here comes the global variable token, and here I will also make some typo, so that you see how typos interact with my workflow. And then I continue with the declaration for this function getToken, and then it's time to compile again, and not much harm done. Now it compiles, and now I can continue. And here I just do these comments for the implementation of the Lexer and also for the test program. And then I also write these comments, these to-dos for the next slide. So now 2 things are left to do: the implementation of function getToken and also the implementation here inside of function main for testing getToken. Now getToken I consider as the more difficult task, and I prefer to do the more difficult tasks more at the end so that I better can focus on them, and I also prefer that I already have a test for these difficult things first so that I immediately see whether I am on the right track. So what you will see is that I actually start in function main. In the end, the test will look like that, but it will not look in its first version like that. I also start here easy, simple. For example, by just writing this while loop without this loop body. This will require that I already have some implementation, some simple implementation for getToken, otherwise I cannot compile it into an executable. So this very first version here will simply always return end of input. And once I have a test which compiles and doesn't give an error when I run the program, I will step by step go through these cases and implement the rest of function main. So that's a while loop which checks whether getToken returned end of input. In this case, the program should terminate, and this will happen if I just leave out the loop body, but I get a linker error because the implementation does not exist. So let's start with some simple implementation. This first version will always return end of input, and it also will set token to end of input. And after that, I should actually get an executable, and I can run the executable, nothing crashes. Now this actually can be done here in one line. Setting the token to end of input and returning the value can be done like that in one line. And these two things belong together, so I consider this as good coding style. Okay, and then I can begin with checking special cases. For example, that token is a decimal literal, and here you see there is a typo. But yeah, this doesn't matter because if you compile often, you easily can catch these things. Now, once the test for one case works, actually you should also compile and run it, you can implement the remaining cases in a similar way. And then in the end, I also want to test whether I forgot one case. Maybe later I add some enum constant for a new token kind, and this last else will deal with that. Okay, and here I just change the strings and the enum constants for each case. And then in this last case, I simply will print unknown token and also the integer value for the token kind that was found. So a simple test, and now actually we can think about to implement getToken. But before we deal with the actual implementation of function getToken, I would like to ask you to make the following modification to it. You will see with this modification, the function will return the first time the value plus, the first time you call it, and the second time the value end of input. Let's go through this. Initially, token has the value getToken. That means when you call it the first time, this condition will be true. It therefore will set token to plus and then return the value plus. The second time you call it, this condition will be therefore false. And therefore we will reach this return statement here, where we first set token to end of input and then return this value. That means with this modification, the following will happen when we run the program. The first time we call getToken, it returns plus. That means the condition is true, it's not end of input. And that means we enter the loop body. And then we actually test whether getToken not only returned plus, but also did set token to plus. So that means if we did this correctly, it should print plus. Because it would be a very simple mistake to forget here this token equal part, maybe also here. So this is something that wasn't tested so far. And of course you could change it so that every possible case here gets covered. So now, as we do have some form of test for getToken, we can focus on getToken. And here I first want to illustrate the algorithm for getToken in form of a board game. A board game where you do have different fields, a field S, a field D, another one is called P, another one is called E, and one last one is called B. These fields are connected. When it's your turn, you're always initially here, and from this field you can move to S back. You can stay on this field if you draw from a stack of action cards a white space card. Or you can move from S to D if you draw a digit card. So a card with one of these faces, a digit from 0 to 9. Or when you're on field D and you draw a digit card, you stay on this field. If you're on field S and you draw a plus card, so a face like that, you move from S to P. If you are on field S and you draw an end of file card, EOF, then you move from S to E. And if you are on field S and you do not draw a white space card, not a digit card, not a plus card, not an end of file card, then you move from S to B. So I simply write here else. So when it is your turn, you always start here, you draw a card, and if you can move, you move. You keep this card and take the next card. So let's assume cards come in this order. The first card would be a plus, the first card that you can draw. The next would be a white space card. The next would be a card with face 1, then one with face 2, then one with face open parenthesis, and then an end of file card. So it's your turn. You draw this card. So this is yours now. You can make a movement. You move to here. But that's it for this turn. For you, you reach this field. From this field, you cannot go any further, no matter what card comes next. So you shout P. I found P. And it's the turn of player number 2. Player number 2 starts also here. Looks at this card, also takes this card, because with this card you can make a movement, even if you stay on the field. Then picks another card, looks at it, also takes it, because you can again make a move with it. Then looks at this card, keeps this card, because you can make a move with it. You stay on D. Then looks on this card, but with this card, player number 2 cannot make a move. From D, you only can move if you find another digit. So that's it for player number 2. Player number 2 reached D, shouts, I found D. And it's the turn of player number 3. Player number 3 also starts here at S, looks at this card, takes this card, because with this card you can move from S to B. It's not a white space, it's not a digit, it's not a plus, it's not an end of file card. So it's a kind of else card. So this player will move to here. From there, you cannot go any further. So this player also will shout, I found B. So it's the turn of player number 4, who also starts here at S. This player looks at this card, EOF, the end of file card. With that card, you can make a movement from S to E. Then, of course, from there, no going further. So player number 4 also shouts, I found E. So with that, you can describe how to detect in a sequence of characters these different tokens, decimal literal, the plus, end of file or end of input, or a bad token. So based on this finite state machine or this board game, we can come up with an implementation for get token like that. But you see, we also have an additional global variable, ch. In terms of the board game, this value of ch represents the current action card, which means that when we enter get token, ch is basically the action card the last player left behind, because the last player couldn't move with this action card. Or we have to take into account one special case. When we call get token the first time, or when the first player has its turn, ch is not initialized. For a global variable, it means it has the value 0. And this will be taken into account here. Now let me visualize what it means that we enter function getToken. It means that we are on the field S. Then we first will check with this first while loop whether we have some card or get another card which leaves us on this field. So if the current card is 0, that means it's the first time we enter this function, or the current action card is a space or a tab or a new line, then we consume this character, or we keep this card and pick the next card and set ch to the value of the next card. And that means in this while loop, we will stay on field S. If we then get something which gets us out of this circle, for example a digit, then we move to field D. On field D we will stay if we get another digit, and after that another digit, and so on. This happens with this while loop. Whenever we have a digit, we keep it and therefore set ch to the next character that we read, until we get something which is no longer a digit. In this case, we return from the function. The next player gets its turn. If we are on field S and get a plus, we also keep this card, set ch to the next character, and simply return. A special case is if we get an end of file, then we actually don't have to keep this card and pick the next card, because when you reach the end of file, there is no next card. So here is no ch get character. If we get something which is not listed above, or not taken care of above, it means we are in the case that we got something else, and then we have a bad token. We consume this character and return bad token. Okay, that's it, and now I show you how to implement this in my way, step by step. So I begin with the while loop for skipping the white spaces, and here I forgot to define this global variable ch. Common mistake. And you should get familiar with some error messages, like for example this undefined identifier. It means that either you haven't defined the variable or you made a typo. For example, if you would type a uppercase C, then you also would get this error message. So no big deal. Now it should compile, and it also works. It's skipping white spaces, and when I hit Ctrl D for end of file, it's terminating the program. Now I begin with some case for a token that should be recognized, for example this plus sign. And here I forgot to consume this character. I forgot to override ch with the next character, which should result in an endless loop, as you see here. So you can stop that with Ctrl C, then you fix the problem, you read the next character, store it in ch, and now this problem should be fixed. So all these tokens were recognized, and now with this I can go to the other cases. the end of file I want to handle inner else if, and in this last else I want to handle all the cases that were not handled above, the bad token cases. And here I should consume the character. So now some pluses, some bad tokens, some arbitrary characters. So this works, but now let's assume I forgot to consume the character. Then I again should get this endless loop. Yeah, Control C and fix the problem. And then I can handle the last case that I got a digit, a character from 0 to 9. So in this case, the same pattern. I consume the character. That means I read the next character, store it in CH, and then I return, in this case, the decimal literal. And now it almost should work. Except, for example, new lines are not recognized. So this is a white space character that I forgot. So I fix that. Test it again. And now hitting return a few times should no longer give me a problem, but I forgot the tabs. So I also fix that, and now this also should work. Let's test this. Yeah. And that's it.